Hello, everyone. Today, I would be working on some of the challenges I faced while simulating uh, grasping on Gazebo. And this video is mostly about the learnings which I got while doing this, so that when you want to try implementing grasping on any of the uh, parts for just like prototyping and just demonstrating what you want to do, you could use this in your future simulations. So let's get started. The main motivation for me to work on this was that while doing the chess robot, there are all small coins, and if they are not grasped properly, the whole game can go as a disaster. Like you can see that uh, the chess coin is never released over here because the grasping plugin is still having it as contact, or the grasping plugin doesn't even come in because the contacts are not realized. So the main tools which I use to kind of resolve this problem is something which I'm going to share so that you can use it as well. Um, First of all, let's understand what the Grasp plugin is doing so that we can troubleshoot this and try to solve this in a systematic manner. Uh, in the first step, like this Grasp plugin, what it does is that it analyzes which are the gripper links and which are the palm links. And whenever it finds there is a contact and the contacts between them are of like does has an angle difference of 100 degrees, and also the number of contacts which it has received is about 8. And if these conditions are satisfied, what it does is that it converts the link between this movable chess coin and the gripper into a fixed link. Once it does that, it becomes a part of the same object and then it doesn't slip. This is something which is a really useful thing because we're not trying to solve the grasping problem here. All we're trying to do is that we want to demonstrate demonstrate what the intention of this robotic system is. So moving further, but what are some tools which we can use so that this Grasp plugin is working properly in our system? Um, One thing which you have to learn is that there is an option in Gazebo which kind of shows you what the collisions are. And this collision can be set into anything. For example, here the collision is set like a box, and over here for the king, the collision is set as the STL model itself. So the orange color representation is nothing but the collisions which is around this actual part. And this is the integral part behind the Grass plugin working. And I'll explain this in more clearly in the upcoming slide. And the next one is that the like as I mentioned, the Grass plugin works really well if the contacts are of 100 degrees apart. So we need to see how the contacts are actually acting on this part. And this kind of visualization, which you can see, which Gazebo offers, is really cool because it shows us that where the contacts are. For example, it shows 4 points of the collision, which is exactly what the rectangular box, if you place it on a chessboard, that's what it's supposed to show. And this will be helpful because we're using a gripper and a chess coin. So we need to see if the contacts are being made, only then the grass plugin will come into picture. And this gives us the granularity to see where things are going wrong. Before all this, what was happening is that that too when I was having the collision as the STL model itself, uh, the if you see here, the contacts are quite random, and you can see these angles are quite different, and it so happens that these contacts are not perfectly 100 degrees apart, and there are not enough contacts as in like 8 contacts for the gripper and the coin to become a fixed link. These tools, such as contacts and collisions, gave a clear idea of how to solve this problem, and that's exactly where the problem lies. Having the STL model as the collision itself uh, can make it a little bit more challenging problem in order to do the grasping. And the next thing is that different pieces have different STL models, and you have to do trial and error to figure out which exact point of the chess piece do you have to grip, and how much distance between the gripper should you have in order to have the right grasp. So this can become really challenging, and trying to do it for every single piece and making that repeatable and reproducible becomes a really tough problem. So, in order to solve that, what I went about doing is that I created these boxes, bounding boxes for these chess coins, um, and made that as the collision surface. By doing this on the collision level, we do not affect anything to the physical appearance. The physical appearance remains the same, but we have the collision being depicted as a box so that now we can have a much more reliable gripping, which I will show in the next slide. So in order to do this, this is the place where we define what kind of collision we want. Here you can see that I put in as a box, and then the box in the pose of this box. Uh, and then this is where we control the gripper gap. And this we try to tune it based on like the overall, each chess piece will have different bounding boxes. And based on that, we tune the gaps so that we have a proper grip on all the different pieces. And here on the top right, as you can see here, is that the Gazebo grass fix. This is where the plugin is coming to picture. And whenever the plugin is working properly, you will see that the link, there is a fixed link being added, and the gripper and the chess piece is being joined as one single entity. And when it moves far apart, it shows that it has detached. um, this is exactly what you're supposed to see if you have got all the um, collision, contacts, everything set properly. So when I implemented all of these collisions into a bounding box instead of the chess piece itself, the contacts were pretty reliable, as in you can see that these contacts are perfectly 180 degrees apart, and they kind of give a lot more contacts than just having the chess pieces FTL model, which can be a little bit tricky. And by doing so, we kind of see that we have enough number of contacts, and also it's in the perfect separation angle, and the grasping goes as expected. So this is kind of like a trick which I used to solve this problem. Uh, but there are um, several other options which you can explore, which is the friction coefficients, which are here, and the uh, how much can different, like two objects with collision, um, interfere with each other. All these are some of the options here which you can explore to actually simulate a proper grasp. Because my whole motivation was to get the overall system working. I didn't get into the granularity of this, but this is a way you can surpass this problem and work on a bigger problem as creating the system or working on the perception and stuff like that. So hopefully this kind of insights will help you model your system better and enable grasping easier. And hopefully you are able to get your project working and show the overall intended purpose as required. Um, Thank you, guys.